Hello, hi everyone. Welcome to this Two in the Brand. So you can see now we are going to discuss about light reflection and refraction. We'll discuss this chapter. Okay, light reflection and refraction. So the chapter will discuss. Light reflection and refraction chapter will discuss. Okay, so in this topic in the previous class we discussed all the chapters, right? Light reflection and refraction, human and colorful world, electricity and magnetic effects of electric current. As I said, all those chapters. Now, so we'll completely work out on today topic, light reflection and refraction, light reflection and refraction chapter. So purely, so we'll work out on it. If you have any doubts related to light reflection refraction, so you can comment, ask doubts related to. Okay, so light reflection refraction chapter. I'll be explaining one by one. So those who have any doubts can ask me. And the remaining chapters, as I said, human and colorful world, magnet effects of electric current, and electricity topics. So it's going on. Electricity live class today at 9 p.m. So everyone, those who are attending now, those who are watching the live class, can attend the live class at 9 p.m. So why I came now it means, so light reflection refraction chapter full pledgely we didn't discuss till now. So we are discussing reflection part or refraction part, but completely we need to discuss light chapter. That's why I came. And here, so myself, I'm Siva sir. Myself, so CBSE Grade 10 Physics by Siva sir. So Siva sir, BTech Mechanical. So 10 years experience in physics teaching, 10 years experience in physics teaching. So if you want like any doubts, if you have any concerns, any tuitions from 6 to 12th, okay, 6th class, 7th class, 8th class, 9th class, 10th, 12th, 11th, 12th, any topic, okay, so related to physics or remaining subjects also, remaining subjects those who want, you can contact to this number. Okay, so now today CBSE Grade 10 Physics light reflection and diffraction part we'll discuss. Light reflection and diffraction. So in detail I'll discuss light reflection, reflection and refraction and refraction. Okay, so light reflection and refraction topic. So very important chapter it is. So very easiest chapter also, because in this chapter diagrams only. So most of the diagrams will come. Okay, so diagram related chapter. This chapter and human and colorful world and magnet effects of electric current. So very easiest chapters because all related to diagrams. And coming to the electricity theory as well as problems, we need to concentrate on theory as well as problems. Okay, 100 problems at 9 p.m. 9 p.m. So we'll be having electricity problems, 100 problems. See, I am planning to do 100 problems, okay, series. If it is possible we'll continue. Okay, otherwise a few problems definitely we'll discuss. At least models will cover. Remaining models will go to the next one, or I will try to give homework, or so we'll plan. Okay, so my plan is, so we need to work out on 100 problems. That is our plan. Okay, 100 problems must be covered, right? Yes. So light reflection and diffraction chapter. In the chapter, light is a form of energy. So in detail I said, so each and every point I'll discuss in detail. So light is a form of energy. Light is a form of energy which will give the sensation of sight. Okay, so normally sound, you can see sound is a form of energy which gives the sensation of hearing. Sensation of hearing. But here light is a form of energy, so which gives the sensation of sight. So here just you can close your eyes. Will you able to see anything? No, we can't able to see anything. Okay, once you open your eyes only, then we can able to see beautiful world around us. Beautiful world around us. Hi, someone said hi. So what is your name? I couldn't recognize Hemanta or some. Okay, fine. So whoever there in live class, just say hi and ask doubts. Ask doubts. I am trying to clarify your doubts. I'm trying to rectify your doubts. So okay. So maximum I'll try to interact. So it's an interactive class. So you can ask doubts. We'll get the clarification. I'll explain the chapter. So in detailed. Okay. So those who are attending the class, just you can make a note. Okay. Make a note one by one. I will discuss light reflection diffraction. So light is a form of energy which gives the sensation of sight. When light falls on it, then only reflection takes place, then it will comes out from the surface, right? So I'm taking the surface, so I'm considering this surface. Here is a surface, so I'm taking the plane mirror. This is a plane mirror, like this. This is a plane mirror. So again 9 p.m. live class will be there. Live class at 9 p.m. Live class at 9 p.m. Okay, so join everyone. So today only, okay, today only live class. So you can join to the live class once again. So now I am taking, so 9 o'clock I will be having electricity problems. Electricity problem. So I am taking the incident ray. This is the incident ray. So incident ray. This is the reflected ray. This is the reflected ray. So incident ray, reflected ray. I'm taking this incident ray. So you can consider the light which is incidenting on the surface, that is incident ray. So then it is a reflected ray. Incident ray, incident ray, incident ray. And this will be considered as the reflected ray, reflected ray, reflected ray. And the line which is perpendicular to the surface, the line which is perpendicular to the surface, this is the normal line. The line which is perpendicular to the surface, this is called normal line. Okay, normal. Actually this line is not there. Okay, it does not exist. For our understanding, of phenomena of reflection of light, we are drawing. Okay, so we are simply drawing this line. So that's why we are drawing with the dotted line for understanding, for analyzing the reflection phenomena. So we are using this normal line. So this is the normal line. If you are taking this incident ray, extending incident ray, I'm taking like this. Okay, so undeviated line, extended incident ray, undeviated line we are considering. So the angle between incident ray and normal line is called angle of incidence. Angle between reflected ray and normal line is called angle of reflection. So here you can observe. Here you can observe the angle between incident ray and normal line is called angle of incidence. Angle between incident ray and normal line is called angle of incidence. Angle between reflected ray and normal line is called angle of reflection. So this is the reflected ray, and the angle between reflected ray and undeviated line is called angle of deviation. Angle of deviation. So this angle is called angle of deviation. Now we can take. So there are two laws of reflection. Laws of reflection. So we can say laws of reflection. Laws of reflection. There are two laws of reflection. So angle of incident is equal to angle of reflection. So first one you are taking, angle of incidence is equal to angle of reflection. Second one, angle of incident is equal to angle of reflection. Second one is incident ray. So incident ray, reflected ray, normal line lies on the same plane. Incident ray, reflected ray, normal line lies on the same plane, because so it exists on the same plane. So these two are laws of reflection. So very important. So make a note of it. Very important. Laws of reflection. Laws of reflection. Okay. So incident ray. Here this is the incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line. So the angle between incident ray and normal line is called angle of incident. Angle between reflected ray and normal line is called angle of reflection. Angle between reflected ray and undeviated line. So here this light ray does not deviate, because normally there are two types of mediums, homogeneous medium and heterogeneous medium. In homogeneous medium, light does not deviate. Okay, so path of the light does not changes. So whereas undeviated, like you can see non-homogeneous medium, like heterogeneous medium, when light enters from one medium to another medium, so the path of the light changes, the direction of the light changes, the direction of the light changes. So that is a heterogeneous medium. So in homogeneous medium, light ray, okay, so it won't deviate. So you can see, so it is undeviated line. Okay, the angle between reflected and undeviated line is called angle of deviation. Angle of deviation. I hope it is clear. So loss of reflection. Angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. So you can see there. Clear? So now you can see these are the laws of reflection. Laws of reflection, right? Yes. So just once note down. Check once. Check once, everyone. If you have any doubts, you can ask. So incident ray, reflector ray, normal line. If you have any doubts, so we can work out. Just check once. So what are the points involved in it? So here, what are the terms? What are the points involved? It is incident ray, reflected ray, normal line, undeviated line. So this is the surface. A highly polished smooth surface is called plane mirror. A highly polished smooth surface is called plane mirror. So here loss of reflection. Coming to loss of reflection, angle of incident equal to angle of reflection. Angle of incident equal to angle of reflection. And incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line lies on the same plane. Lies on the same plane. Okay. So this is about reflection of light. Reflection of light. Loss of reflection of light. Then we'll go to the angle of deviation. So coming to the angle of deviation. So here you can take the linear angle. So what is the linear angle? How much is the linear angle? So I'm considering this a linear angle. So this angle is 180 degrees. 180 degrees. Linear angle is 180 degrees. So this linear angle consists of angle of incident plus angle of reflection plus angle of deviation. So if you are taking in this way, so this is the angle of incidence, angle of reflection, angle of deviation. Okay, so this part angle of incidence, this part angle of reflection. So angle of incidence plus angle of reflection plus angle of deviation. So that is equal to 180 degrees. That is equal to 180 degrees. So I am taking now. So you can see same diagram I'm drawing here. So you can see I'm taking like this. So angle of incidence, angle of reflection, angle of deviation. So angle of incidence plus angle of reflection plus angle of deviation. So angle of deviation. So actually, so three parts. If you are dividing into three parts like this, these are the parts. These are the parts I'm taking. Right now, so in the same case, like that if you are taking, so here you can observe, so angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. So angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Sir, just now you explained about loss of reflection, right? Loss of reflection. What are the loss of reflection? Angle of incident is equal to angle of reflection. So this we will use. Okay, this law we will use. Here instead of angle of reflection, so I'm substituting angle of incidence. Angle of incidence, if you substitute, then you'll get angle of incidence plus angle of incidence plus angle of deviation equal to 180 degrees. So in the same manner, if you are taking angle of deviation, if you are taking from here, angle of deviation equal to, so here angle of incident plus angle of incident, so here angle of deviation, so angle of deviation we are taking 180 minus, so 2 angle of incidence. So in the same manner, if you are taking angle of reflection also, in the same manner angle of reflection if you are taking, so angle of deviation equal to angle of deviation, so I'm taking like here angle of deviation equal to 180 minus, so 2 angle of reflection, 2 angle of reflection, right? R also I'm considering. Why I'm considering here? Sir, you said angle of incident equal to angle of reflection, angle of incident equal to angle of reflection. So in that manner, so we can take angle of deviation equal to angle of 180 minus 2 angle of incidence. So angle of deviation equal to 180 minus 2 angle of reflection, 2 angle of reflection. So this is about completely about angle of deviation and reflection phenomena. So reflection phenomena is nothing but the bouncing back of the light from surface, the bouncing back of the light from the reflecting surface. So simply we can say when the light incident on the surface, it reflect back into the same medium. So what are the terms involved in it? Incident ray, reflected ray, normal line. So this is the undeviated I am considering, right? So this is about the bouncing back of the light from the reflecting surface is called reflection of light. See, in the exam, in the board exam, surely they will ask about last related to last one question they may ask, and expected question is reflection definition and angle of deviation, related to angle of deviation. And here one more thing you have to understand, so you have to understand one thing, angle of incident is equal to angle of reflection, angle of incident equal to angle of reflection, right? Angle of incident equal to angle of reflection. So this question surely they will ask, because so these points whatever we are discussing, these very very important points, so make sure that so you are writing and you are noting down. You can so after live class if you are watching also fine, just you can stop it wherever you need to understand, you want to understand, you want to write a notes, you can stop it and note down. Okay, so because whatever points I'm discussing, all those points are very very important, so make sure that you are planning notes. Okay, so I already written notes, actually handwritten notes I did, so it is there with me. So those who want handwritten notes, you can contact to this number. So handwritten notes, for handwritten notes you can contact to this number. For your tuitions also you can contact to that number. And coming to the next one, types of reflection. So we'll talk about types of reflection, types of reflection, types of reflection, types of reflection. So there are two types of reflections are there. There are two types of reflection. One is regular reflection, regular reflection, regular reflection. Second one is irregular reflection, irregular reflection, irregular reflection, regular reflection and irregular reflection. So what is the meaning of regular reflection and irregular reflection? Regular reflection means so reflected incident beam is parallel, but reflected incident beam is parallel, reflected beam also parallel. This type of reflection is called regular reflection. Whereas irregular reflection means so incident beam is parallel but reflected beam is not parallel. So we'll see the diagram. Okay, so I'm considering the regular reflection. So you can see regular reflection, regular reflection, regular reflection. So regular reflection. So I'm taking the plane surface. So this is a plane surface. I'm taking the plane surface. So incident ray. So this is incident ray. This is also incident ray. This is also incident ray. So all the parallel light rays are incidenting on the surface. All parallel light rays are incidenting on the surface. The reflected light rays also parallel to each other like this. Reflected. So incident beam is parallel. Incident parallel beam. So here reflected parallel beam. So here what we can say, when the light rays are incidenting, those are parallel to each other. So it's like a incident beam. So reflected beam also parallel to each other. Then this type of reflection is called regular reflection. So here regular reflection takes place on smooth surface. Smooth surface. Smooth surface. Smooth surface I am taking. So that smooth surface is plane mirror. So I am considering here example plane mirror. Plane mirror, smooth surface, plane mirror, right? So incident beam is reflected beam also parallel. Then this type of reflection is called regular reflection. Okay. Then see here where regular reflection takes place on highly polished smooth surface mirror. So where regular reflection takes place, plane mirror, plane mirror. And the second one still water. So second one you can consider still water. Okay, still water, still water, still water means it acts as a smooth surface. So regular reflection takes place on plane mirror and still water. So definitely here they will ask about difference, regular reflection or irregular reflection. So where exactly it is happening, the type of questions they will ask. Now I will see irregular reflection. I am taking irregular reflection. Irregular reflection. Irregular reflection. So where irregular reflection takes place, how it will be, you can see now. So irregular reflection takes place on a rough surface. So I am taking here. So incident ray. So reflected ray like this. So here you can observe incident beam is parallel. Incident parallel beam. But reflector light rays. So reflector light rays are not parallel to each other. Reflector light rays. Reflector light rays are not parallel to each other. So this type of reflection takes place on rough surface. So this is the rough surface. Rough surface. Rough surface. Okay, rough surface. So you can see first one where this reflection takes place. First one is book table, also we can say book table. Okay, table or a wall surface. So wall like this. So irregular reflection takes place on book, table, and wall also, because this is the this is about irregular reflection, and this is a rough surface, right? Yes. So now we will go to the next one. So I hope it is clear to you, right? Yes. So I'll explain one more. Okay, so we can take object and image related to plane mirror only. I'll explain related to plane mirror, object and image I'll explain. Then we'll go to the nature of the image formed by the plane mirror. First we'll discuss about object and image, so how it will be. Then we'll go to the nature of the image formed by the plane mirror, nature of the image formed by the plane mirror. So after that we'll go to the spherical mirrors. So then later we can go to the ray rules, image formations and sign conventions. Then after that mirror formula, magnification. After that we'll go for lens. So like that topic will go on like a flow. So just you can observe and watch, right? Yes. So now we can go to the next one. So what topic I'm taking? So object and image. So object I'm considering. So object in the sense this, now I'm taking a mirror. So this is a plane mirror. This is a plane mirror. So I'm considering here principal axis. So here is the object. So here is the object. One light ray I'm taking here. From here one light ray I'm taking like this. So it will be reflected back. One light ray I'm taking, it will be reflected back. Another light ray I'm taking like this. So this also will be reflected back. Okay. So if you are extending this light rays, you can observe I'm extending this light rays. So this light rays I'm extending. So light rays will meet here. Okay. So here is a real object. Real object. So virtual image. Real object and virtual image. Real object and virtual image. Right. So here, so I'm taking real object and here it is a virtual image. So what is the real object definition and virtual object? So here I'm taking object is real, real object, image is virtual, image is virtual. So related to, so I'm taking this a case one. Case one I'm taking. So object is here. You can observe when the object is real, image is virtual. So the point of intersection of extended reflector light rays. The point of intersection of extended reflector light rays. The point of intersection of extended reflector light rays is called virtual image. So we are extending the reflector light rays. So the image is forming here. So here we can take the light rays are coming from one point. Okay. So real object. Light rays are coming from one point. So this is a real object. So I am taking one more diagram. You can observe carefully. So light rays are coming from one point like this. So here we are reflector light rays directly meeting here like this. So if you are extending these light rays, okay. So here real image. Image is real, virtual object. Image is real, virtual object. So here you can observe the point of intersection of, here you can observe the point of intersection of reflector light rays. Directly these reflector light rays are meeting at one point. The point of intersection of reflector light rays is called real image. Here the point of intersection of extended incident rays. So this is the one incident ray, this is one incident ray. So we are extending those incident ray and those incident rays are meeting at one point. Those incident rays are meeting at one point. So their image will form. So that is a virtual object. So from this we can conclude that. So second case, case 2, real image, virtual object, real image and virtual object, real image and virtual object. Real image and virtual object. Clear? Yes. So from we can conclude that, we can conclude from it, from here. Object and image here. Object and image. Object is real, image is virtual. Object is virtual, image is real. Okay. So plane mirror you can observe. You can observe here. So we can conclude from these diagrams. We can conclude from these diagrams. We can conclude that object is real. So real object, virtual image. Real object, virtual image. Real object, virtual image. Right? Here. Thank you so much. Okay. So here you can see. Now I am taking these are the incident rays. These are the incident rays. So after reflection, those light rays are meeting at one point. So these are the reflector light rays. So those after reflecting, the light rays are meeting at one point. So here it is a real image. So we are extending this incident rays. We are extending this incident rays. Those incident rays are meeting at one point. Those incident rays are meeting at one point. So here we can say that is a virtual object. Virtual object. So you can observe now. You can very important, very important, very important, because so object is real, image is virtual. Object is image is real, object is virtual. Vice versa. So this point is very important. Now in the exam also they will ask. So in plane mirror. So in the plane mirror we can see. So in the plane mirror, object is real, image is virtual. Object is virtual, image is real. So you have to remember these points. These points are very important. Scientifically designed vice versa. So nothing else, simple only, simple points only. But if you say that word, no, so our mind will concentrate more. Scientifically designed. Oh my God! So it's a very valuable word, like a great word, like a solid word, right? Then we will focus more. We'll focus more like that. So simple only, very easy only. Object is real, image is virtual. Object is virtual, image is real. See, it's not only for grade 10 CBSE physics, it's also helpful for grade 12 students, those who are studying, and even for those who are writing competitive exams and those who are writing NEET exams, and presently who are going to write 26. So 26 NEET exam and J exam who are writing. So these points are very important because I am explaining in depth. So point to point I'm explaining, topic to topic I'm explaining. So make sure that keep an eye and focus. Okay, focus. If you focus, that's enough. So very simple only. So next one we'll go to the plane mirror. Nature of the plane mirror. Okay. So is it clear? Any doubts? Shall I arise? So you can take a screenshot. You can take a screenshot. Okay, or you can note down. Shall I? Shall I? Okay, done. Now I am taking now. So I am considering. So I am taking one more. Okay. So plane mirror I am considering. This is a plane mirror. This is a plane mirror. So one side is coated, another side is reflecting surface. Okay. So I'm taking a image. Here I am taking image. Sorry, what is this one? Object. This is object. How many light rays are required to form the image of the object? Minimum 2 light rays. So 2 light rays. 2 light rays. 2 light rays. How many light rays are required to form the image of the object? Minimum 2 light rays. So I am considering like this. So 1 light ray I am taking. 1 light ray I am taking like this. So it will be reflected back. Another light ray I am taking like this. So it will be reflected back like this. Okay, so one more light ray I am taking, it passes. And another light ray I am taking like this. So it will be reflected back. Okay, actually the type of image will form here is virtual image. Virtual image will form. So this principal axis I am drawing here. Here why I am taking is here this is also reflector light ray only. This is also reflector light ray only. Okay, so I am taking here. I am taking here, see. So like this. So I am considering here. So here. Okay. Now this is the A dash and B dash. A dash and B dash. AB is the object. Object, here is object. This is the object I am taking. This object. This object, this is the image. Object and image. So I said how many light rays are required? 2 light rays are required. So I'm considering here. This is the object, right? This is the image. So 1 light ray I am taking here. This is 1 light ray I am taking here. This is also 1 light ray. So this is a reflector light ray. Here more you can, for understanding I am drawing like this. So this is the incident ray. This is the reflected ray. Here also incident ray. This incident ray. Reflected ray. Okay. So for what purpose I am mentioning here. Here you can see this reflector light rays. These are the reflector light rays. Reflector light rays are beating at one point. Here also reflector light rays. So why we are drawing with the dotted lines? Because image is virtual image. What type of image will form? Virtual image will form. Virtual image. What type of image will form? Virtual image. What type of image will form? Virtual image. What type of image will form? Virtual image. So in the previous cases, I hope you got it. Object is real, image is virtual. Object is virtual, image is real. Okay, so like that, vice versa. Vice versa we are considering. Okay, so here also the same. If object is real, image is virtual. Object is virtual, image is real. Here there are 3 points we need to discuss from this case. So characteristics. So I am considering first one is first one is okay. So first one I am taking object is real. Object is real, image is virtual. So object is real, image is virtual. Okay, vice versa, real and virtual, vice versa will come. And the second point is, so object distance is equal to image distance. So what is the object distance? I am taking this object from object to mirror. From object to mirror is called object distance. So I am taking this object distance from image. So this is the image. Image to mirror is called image distance. From object to mirror is called object distance. Object to mirror is called object distance. So image to mirror is called the distance between. Here very important points. Very important points. Okay. So we need to learn these points. These are very basics. So what are those? object distance. What is object distance? Object distance is nothing but the distance between object to mirror. The distance between object to mirror is called object distance. Image distance is nothing but the distance between image to mirror. So the distance between image to mirror, okay, image and mirror, so then that is called image distance. So here in the plane mirror, I am considering this a plane mirror. So in plane mirror, object distance is equal to image distance. And third one, if you are taking third one, height of the object is equal to height of the image. So this is the size. Okay, so this is the distance, right? Distance is different, size is different. Object height. Okay, so here in this case only you'll get magnification is positive. Magnification is positive. So in which mirror you will get magnification is positive? Only plane mirror. Only in the plane mirror only you will get a magnification is positive. So magnification -1 in concave mirror. In concave mirror and convex lens also. Convex lens also will get, in concave mirror also will get magnification -1. But only positive case, only positive magnification will get in the plane mirror itself. So that is nothing but height of the image equal to height of the object. Height of the image is equal to height of the object. Height of the image is equal to height of object distance is equal to image distance. Object distance is equal to image distance. Height of the object is equal to height of the image. Height of the object is equal to height of the image. And so if object is real, image is virtual. Object is virtual, image is real. So very, very important points. So make sure that you are noting down. And fourth point is very, very important. See, any one question diagram will get for 3 marks. Will get so they will ask for 3 marks. Complete question. This complete question. Sir, how they will ask? Okay, so explain about nature of the image formed by the plane mirror. Okay, so 3 marks question they will ask. For 3 marks, 3 marks they will ask. And here also 1 mark. So 1 mark they will ask for. So here 3 marks question and 1 mark question. So how they will ask for 1 mark? So in a plane mirror, MCQs point of view, they will ask object distance is equal to image distance and height of the object is equal to height of the image. So what about a magnification, positive or negative? Magnification is positive. In plane mirror, magnification is positive. Okay, very good. So that's enough. That is about these points. Next, lateral inversion. So it also shows lateral inversion. Lateral inversion. So what is a lateral inversion? Lateral inversion is nothing but the phenomena of converting of right side of the object appears to be left side of the object appears to be right side. So I'm standing in front of you. Okay, so like in the mobile you can see. So I'm lifting my right hand. So it appearing in the left side. So if I'm lifting my right hand, so it is appearing in the, so you can see now you can observe. I'm lifting my hand, right hand. Okay, it's appearing in the camera left side like this. So if I lift my left hand, it is appearing in the right side. It is appearing in the right side. So this mirror conversion. So this is my right hand. So in the mirror it is appearing left side. So this is my left hand. It is appearing in the right side. So the phenomena of converting of left side of the object appears to be right side. Means now it is right hand. Right side object appears to be left side. Left side object appears to be right side of the image. Once again, right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. So this mirror conversion is called lateral inversion. This mirror conversion is called lateral inversion. Okay. Once again, what are the points we discussed till now? So first point is object is real, image is virtual. Object is virtual, image is real, vice versa. And the second point is So object distance is equal to image distance. Okay, object distance is equal to image distance. And third point is height of the object is equal to height of the image. Height of the object is equal to height of the image. And fourth point is it shows lateral inversion. So 4 point, simple steps, simple points, very easy. Okay, so diagram, once follow the diagram, these 4 points, if you remember, that's enough. So we'll okay now, so you can learn this topic. So 3 marks question they will ask, 1 mark question they will ask, and 2 marks question also they may ask. So there is a chance, in all the ways, in all the directions, in all the direction, these questions they may ask. Okay, so here you can see. So I hope hard work. So very beautifully written on the board. So I can't able to rub the board because nice, right? Nice one. Clear. So, chalo, note down. So, note down this point. Note down this point. If you like this class, if you're listening the class, please one like. Please one like. So, I'll feel very happy. And the remaining students also, they will. Okay. So, this video will reach to the remaining students also. They will also join and they will also attend. They will also learn. Okay. Next one. So we'll go to the next one. So we'll see. So please note down because very important topic. So I discussed. You can check once if you have any doubts. You can ask. So immediately you can ask. So we'll clarify. I'll clarify your doubts and a few questions I have to discuss. Few questions are there and remaining. See, it will take time. Spherical mirrors, all the points one by one I will discuss. So be patient and attend the class. Or if you want to see the class also fine. After some time you can watch. Okay, done. So now we'll go to the next one. Normally, if you take a stone, and pour a bucket of water on it, nothing will happen. Nothing will happen. But if you take same bucket of water and leave drop by drop on the stone, so slowly and steadily and every day. Okay, so and full of bucket of water. So if you leave, then what happens after some time, after completing a bucket of water, so you can understand that you can observe the difference. The point is, so subject we cannot learn at a time. Okay, so like one night out, if you study, you can't get the subject in one night out. So if you want to learn, so you can't learn complete subject every day, drop by drop. How you are living, drop by drop. If you add, drop by drop. If you save, then after a few days, you can observe the difference. So my point is, so what I'm going to tell is, so learn every day, little by little. Okay, so with the consistent, with the patience, with the dedication, work on it. One day you'll get the difference. One day you will get the difference. One day you will get the subject in the greater point of view. Okay, so try to work out. Try to work out. Learn the subject. Learn the subject. That's enough. Try to learn the subject. Try to learn as much as possible. Automatically marks will come. Marks are the byproducts of subject. If you learn the subject,